In this module, we'll explore three key pillars of modern IT infrastructure: virtualization, data centers, and cloud computing. We'll begin by understanding virtualization, the technology that allows multiple virtual machines to run on a single physical system, improving efficiency and resource utilization. Next, we'll look into the data center, the physical facility that houses servers, networking equipment, and storage systems to support large-scale computing operations. Finally, we'll examine cloud computing, where resources and services are delivered over the internet, offering scalability, flexibility, and cost efficiency. By the end of this lesson, you'll understand how these three concepts work together to power today's digital world. Virtualization is the process of creating virtual versions of physical components, such as servers, storage devices, networks, or even entire operating systems. This is achieved using software called a hypervisor, which abstracts the underlying physical hardware and creates virtual machines, VMs, that behave like physical computers. Key components of virtualization. Hypervisor. The hypervisor is a layer of software that sits between the physical hardware and the virtual machines. Virtual machines, VMs. VMs are isolated environments that run their own operating systems and applications. Each VM has its own virtualized hardware, including CPU, memory, storage, and network interfaces. Virtual network. Virtual networking allows the creation of network interfaces, switches, and routers in software. This enables virtual machines to communicate with each other and with external networks. Virtual storage. Storage virtualization abstracts the physical storage devices into a pool of storage resources that can be allocated to VMs as needed. Types of virtualizations. Server virtualization divides a physical server into multiple VMs, each running its own OS and applications. It improves server utilization and reduces hardware costs. Desktop virtualization creates virtual desktops that users can access remotely. It centralizes desktop management and enhances security. Network virtualization abstracts network resources, allowing for the creation of virtual networks. It improves network management and flexibility. Storage virtualization aggregates physical storage resources into virtual storage pools that can be dynamically allocated to VMs. Application virtualization encapsulates applications from the underlying OS, allowing them to run in isolated environments. This simplifies application deployment and management. Popular virtualization platforms. VMware vSphere, a comprehensive virtualization platform for building and managing virtualized environments. It includes ESXi Hypervisor and vCenter management tools. Microsoft Hyper-V, a hypervisor-based virtualization platform integrated into Windows Server. It supports a wide range of workloads and applications. KVM, kernel-based virtual machine, an open-source hypervisor built into the Linux kernel. It provides strong performance and flexibility for Linux environments. Citrix Hypervisor, a high-performance hypervisor for desktop, server, and cloud virtualization. It focuses on security and management features. Oracle VM VirtualBox, a free and open-source hosted hypervisor for running multiple operating systems on a single machine. It is widely used for development and testing. What is a data center? A data center is a facility that houses an organization's IT operations and equipment. It is the central location where computing resources, including servers, storage systems, networking equipment, and other infrastructure components, are housed and managed. Data centers are crucial for storing, processing, and disseminating large amounts of data and are essential for the operation of cloud computing, enterprise applications, and IT services. Key components of a data center. Servers. The primary computing devices that run applications and manage data processing tasks. Storage systems. Devices and systems used to store data, including hard drives, solid-state drives, and storage area networks, SANs. Networking equipment includes routers, switches, firewalls, and load balancers that manage data flow and ensure secure, reliable connectivity. Power supplies, uninterruptible power supplies, UPS, and backup generators to ensure continuous power in case of outages. Cooling systems, HVAC systems, including air conditioning and ventilation, to maintain optimal operating temperatures for equipment. Security systems. Physical security measures such as surveillance cameras, biometric access controls, and security personnel to protect against unauthorized access. Monitoring and management tools. Software and hardware tools for monitoring the performance, security, and health of data center infrastructure. What is the cloud? The term cloud, in the context of computing, refers to the delivery of various services, including storage, databases, servers, networking, software, and more, over the Internet, known as the cloud. These services are hosted on data centers, owned and managed by cloud service providers, CSPs, such as Amazon Web Services, AWS, Microsoft Azure, and Google Cloud Platform, GCP. Key characteristics of the cloud. On-demand self-service. Users can provision and manage computing resources as needed, without requiring human intervention from the service provider. Broad network access. Services are available over the network and can be accessed through standard mechanisms by heterogeneous thin or thick client platforms. Examples: mobile phones, tablets, laptops, and workstations. Measured service. Cloud systems automatically control and optimize resource use by leveraging a metering capability at some level of abstraction, appropriate to the type of service. Examples: storage, processing, bandwidth, and active user accounts. Resource usage can be monitored, controlled, and reported, providing transparency for both the provider and consumer of the utilized service. Types of cloud deployment models. Public cloud. Services are delivered over the public internet and shared across multiple organizations. It is typically the most cost-effective and flexible model. Examples: AWS, Azure, GCP. Private cloud. Services are maintained on a private network. It provides greater control and security, often used by businesses that need to meet specific regulatory or compliance requirements. Hybrid cloud. Combines public and private clouds, allowing data and applications to be shared between them. This model provides greater flexibility and more deployment options. Types of cloud services. Infrastructure as a service, IaaS, provides virtualized computing resources over the Internet. Users have control over operating systems, storage, and deployed applications. Examples: AWS EC2, Google Compute Engine, Microsoft Azure VMS. Platform as a Service, PaaS. Delivers hardware and software tools over the Internet, typically those needed for application development. Users do not manage the underlying infrastructure. Examples: Google App Engine, AWS Elastic Beanstalk, Microsoft Azure App Services. Software as a Service, SaaS, provides software applications over the Internet on a subscription basis. The service provider manages the infrastructure and platforms that run the applications. Examples: Google Workspace, Microsoft Office 365, Salesforce. Additional specialized cloud services. Storage as a Service, STaaS, provides scalable storage resources over the internet, allowing businesses to store and manage data without maintaining physical storage infrastructure. Examples: AWS S3, Google Cloud Storage, Azure Blob Storage. Use cases: data archiving, backup, content delivery. Database as a Service, DBaaS, offers managed database services, allowing users to set up, operate, and scale databases without handling the underlying infrastructure. Examples: Amazon DS, Google Cloud SQL, Azure SQL Database. Use cases: managed database solutions for transactional and analytical workloads. Networking as a Service, NAAS, provides virtual networking services over the internet, enabling organizations to deploy and manage network resources without physical network infrastructure. Examples: AWS VPC, Azure Virtual Network, Google Virtual Private Cloud. Use cases: virtual networks, load balancing, VPN services. Security as a Service, SECaaS, delivers security services over the internet, providing businesses with scalable and manageable security solutions without the need for on-premises security infrastructure. Examples: AWS Shield, Azure Security Center, Google Cloud Security Command Center. Use cases: DDoS protection, identity and access management, threat detection. Thank you for watching this module on virtualization, data centers, and cloud computing. We hope you now have a clearer understanding of how virtualization improves efficiency, how data centers provide the physical foundation for large-scale computing, and how cloud computing delivers scalable and flexible services over the internet. Continue exploring the next modules to deepen your knowledge and strengthen your skills in modern IT infrastructure.